Good afternoon, dear colleagues. Let us present to your attention the report on the following theme: modern warming, medieval and ancient optimums as the result of orbital changes in the Earth-Moon-Sun system. One of the main problems of mankind is a reliable assessment of the climate change trend. Modern warming indicates a thermodynamic violation in the thermal balance of the planet Earth. An international group of climate experts associates an increase in air temperature with an increase in CO2 concentration as a result of anthropogenic impact, but these may be due to both planetary and cosmic climate-forming factors and processes. Climate change problem is as old as the world. It worried scientists at all times, and they tried to give this phenomena an assessment. In the 1st century AD, Lucius Junius Moderatus Columella wrote, "I know that many remarkable writers were convinced on the climatic changes taking place over a long period. Sazerna understands this climate change in such a way that cold areas after the warming and disappearance of the former cold will be covered with olives and grapes." The basis of any forecasting is the search for empirical relationships that allow catching the rhythms caused by natural physical processes and describing them by statistical relationships of various meteorological parameters. Attempts of scientists to identify the cyclical or rhythmic processes especially intensified in the late 19th and 20th centuries. The 11-year cycle most used in research is associated with solar activity. However, many planetary rhythms, as well as multiples of 18, are formed by the celestial mechanics of the Moon, Earth, and Sun in the lunar-solar calendar of events. They are caused by gravitational forces periodically causing acceleration of motion and rotation of the planet Earth and the reverse responses of its geospheres. Centuries-old rhythms are associated with changes in the Moon-Earth-Sun orbital configurations, which are visually observed in the annual movement of the shadow cone of solar eclipses or the total vector of gravitational forces around the globe. Solar eclipses are combined in the Saras series, which consists of 6987 eclipses. The time interval between past eclipse and the one repeating the same characteristics of the position of the Moon, Earth, and Sun in space amounts to 1 Saras, which is equal to 18 years and 11 days. The Saras series lasts from 1226 to about 1550 years, generating centennial rhythms. They gradually pass from partial eclipses in the polar regions to circular and total ones, then again to partial eclipses in the opposite pole. Polar eclipses occur when a series of Saras begins or ends. Maximum number of eclipses per year reaches 5. The difficulty in finding ways of long-term forecasting is caused by the fact that the Earth makes more than a dozen movements in outer space. In addition, its satellite is gradually moving away. There are almost no completely identical situations, including those with solar eclipses. Nevertheless, our studies have revealed not random coincidences in the frequency of extreme conditions, for example, abnormally severe winters. This trend continues in the modern period of warming, for example, 2011's and 2018's years. It was revealed that years with 2 or 4 polar eclipses, and especially those in which the Saras series begin or end, are often cold with severe winters in the Russian plain and Europe, often with a lot of rainfall and catastrophic floods. Years with polar eclipses are often characterized by abnormally cold summers, which, according to Ladurie, contribute to the preservation of mountain glaciers. Our works also show that the recurrence of abnormally hot, dry periods and catastrophic droughts in the Russian plain isn't accidental and has a connection with the Saras series. There have been analyzed in the article the intervals between years with 4 and 5 polar eclipses over centuries, which are the result of the motion of the Moon and the Earth in outer space and the rotation of their orbits. The analysis gave interesting results. In the 1st, 6th, 7th, 12th, 13th, 17th, and 18th centuries, the number of years with 4-5 polar eclipses was maximum, 15-17 cases. Various authors attribute these centuries to periods of cooling and the advance of alpine glaciers. In the 24th century, the number of such years will reach 18 cases. The Little Ice Age, which covered the territory of Europe and its water area, is well described. Its end was determined by the 19th century. However, different authors refer the beginning of the Little Ice Age to the 13th, 14th, or 16th centuries. We adhere to the opinion of Leroy-Ladurie, whose diligent study indicates the dates of the intercentury phase of the advance of alpine glaciers, also called the Fernau fluctuation, between 1600–1850. The Little Ice Age is explained by a decrease in the level of activity of the Sun, the Maunder minimum, and the Gulf Stream volcanic activity, but probably these reasons are secondary. Most likely, orbital factors are in the first place, as evidenced by the sharp increase in the number of years with 4 or 5 polar eclipses up to 15–17 cases in a century. In addition to a stratigraphic analysis of the location of the medieval moraines of the Fernau Glacier, the information found in archival materials finally convinced Leroy-Ladurie in the idea of cooling in the 12th–13th centuries. It is this short-term but almost two-century period of the advance of glaciers, the Little Ice Age of the post-optimum, that many scholars often omit in their analytical descriptions. Climate reconstruction of the Russian plain, northeastern Europe, and the Arctic and extratropical latitudes of the northern hemisphere over the past 2000 years, performed by researchers and presented in the form of changes in average annual temperatures and their anomalies over a centuries-old period, are in good agreement with the number and rhythm of years before 5 polar eclipses over centuries. In recent years, an international team of scientists led by Professor Ulf Böndgen and with the active participation of Russian scientists and researchers, using complex surveys in Altai and the Alps, established the start and end dates of the late antique Little Ice Age from 536 to about 660 AD. The peak of cooling occurred in the middle of the dark 6th century, then volcanic activity intensified. A steady decrease in temperature in the 6th century coincides, as already mentioned, with an increase of the number of years with 4 or 5 polar eclipses to 17 cases in a century, and a decrease in the intervals between them to 3, 4, and 7 years. The catastrophic temperature anomaly of this century, which has covered several regions of Eurasia, is most likely the result of superimposed activation of volcanic activity on cooling caused by orbital causes. The Ice Age in the 1st century AD and 1st century BC hasn't yet been identified. We conditionally gave it the name of Ovidius, since its severity was described by Ovidius as well as by the chronicles of this period. During this time, 22 years with floods were recorded on the Tiber River, and the number of shipwrecks reached 36–37 cases. This data characterized the storm activity intensifying in the era of cooling. Saserna, father and son, wrote that in the last century BC, the production of wine and olives in Italy was complicated by very severe winters. During optimum periods, antique, medieval, modern warming period, the intervals between years with 4 polar eclipses increased and amounted to 11, 18, 29 and more years, and the number of years with eclipses decreased up to 2–6 per century. Probably the 14th 16th century is an optimum that didn't take place in the classical sense. In this interglacial period of the 14th–15th centuries, the number of years with 4 eclipses didn't exceed 7 per century, but the Spörer minimum, which characterizes an almost century-long decrease in solar activity, and maybe other unaccounted factors, played a certain role in lowering the temperature. This period was characterized by significant interseasonal and interannual fluctuations in weather conditions, along with higher temperature than in 12th–13th centuries. Conclusions. Climatic optimums alternate with Little Ice Ages according to a decrease up to 2–7 cases and an increase up to 15–17 cases per century of the number of years with 4 and 5 polar eclipses. Orbital factors are the primary cause of the alternation of the number of years with 4 and 5 polar eclipses per century, and accordingly climatic optimums or pessimums. The precession of the axis of rotation of the Earth and the rotation of the abscess line entail millennial rhythms in the advance and retreat of glaciers. Centennial rhythms are associated with a change in the Moon-Earth-Sun orbital configurations, which are visually traced in the form of the movement of the shadow cone of solar eclipses around the globe. Solar activity, as well as planetary factors and processes, volcanic activity, current intensity, heat transfer with the world ocean, can significantly strengthen or weaken the influence of gravitational forces due to the configuration of orbits in outer space. A number of scientists believe that modern climate change is the next phase of its natural fluctuations on which the greenhouse component is superimposed. Its contribution is about 25%. That models simplified to one anthropogenic factor are erroneous, and the conclusions about the imminent thermal catastrophe of mankind are greatly exaggerated. The fact that these rhythms existed earlier is confirmed by an additional analysis of the repeatability of the number of years with 4 or 5 polar eclipses, as well as the intervals between them, not only for 3 but for 5 millennia, starting from 2000 BC to 3000 AD. Acknowledgements. This work is dedicated to Emmanuel Valduri. Some patterns that were first identified in our studies didn't always find confirmation in the available literature, but thanks to the work A History of Climate since the year 1000, which is a unique example of a competent approach to scientific historical research, everything fell into place. Thank you for your attention.